Hi, today we're talking about hyperbolas. This is from your homework worksheet 9.5, the hyperbola worksheet. Let's start with number 1. Okay, so we need to graph the equation, identify the vertices, foci, and asymptotes of the hyperbola. I put this this box from your note sheet on here because it's really important to have all this information when graphing a hyperbola. A hyperbola is a little bit more involved when it comes to graphing, so it's important that we know what kind we have, a horizontal or a vertical, and then we can use the various formulas to get our asymptotes and vertices. So just as a reminder, if we think about a horizontal hyperbola, just change the color here. A horizontal hyperbola will open to the left and right, so there's your hyperbola. And a vertical hyperbola will open up and down. So identifying that can help us when we graph. We have the standard equation of hyperbolas, and there's two forms of it. We have x squared over a squared minus y squared over b squared equals 1. That gives me a horizontal hyperbola with a hyperbola with a horizontal transverse axis. And then we have y squared over a squared minus x squared over b squared equals 1. And that will give us a hyperbola with a vertical transversal axis, which means that the transverse axis, if you remember, connects the vertices. So to identify if it's horizontal or vertical, we need to look at the order of the x squared or the y squared. If the x squared comes before y squared, then we have horizontal. If y squared comes before x squared, then we have a vertical. So let's take a look at the equation that we have for number 1. We have x squared minus y squared. So here I'm going to have a horizontal hyperbola, or a hyperbola with a horizontal transverse axis, meaning my hyperbola will open to the left and right. So let's start by identifying our vertices. Well, in order to identify the vertices, we need to know what our A and B are. So let's go ahead and just look at our A and B. Our A squared is under x. So to figure out A, we just take the square root of A squared. So the square root is 16, which gives me 4. To figure out my B, I take the square root of the number under y squared. Square root of 4 is 2. So now the vertices in a hyperbola with a transverse axis that is horizontal, the vertices will be plus or minus a comma 0. So they're going to be on the x-axis. So my vertices in this case, let's go ahead and use a different color, are going to be plus or minus 4 comma 0. Then let's go ahead and identify what our foci will be. Well, I'm going to do some math off to the side here to calculate my foci. To calculate foci, it's very similar to when we calculated the foci of an ellipse, where it was c squared equals a squared minus b squared. However, in a hyperbola, it's c squared equals a squared plus b squared. In this case, my a squared is 16, my b squared is 4. So c squared is the square root of 20. C squared is 20. If I take the square root of both sides, then I know that c is the square root of 20. If I simplify that, I could rewrite that as the square root of 4 times the square root of 5, which is 2 square root of 5. And that's approximately 4.47. Now, if I want to write my foci are points, so I need to write them as points. Because I'm dealing with a foci for a horizontal, they're going to be on the x-axis, so they're going to be plus or minus 2 square root of 5 comma 0. Finally, I want to identify my asymptotes. So the asymptotes are the lines in which the hyperbolas will get so very close to, but not actually cross. So if I identify my asymptotes, I use the equation y equals plus or minus b over a x. You notice these are linear equations in the form of y equals mx plus b, where b over a would be our slope. It's actually two different equations, one with a positive slope and one with a negative slope. So we have plus or minus b over a. Well, my b is 2, and my a is 4x. If I were to simplify that, which I'm going to go ahead and write that in different colors since it's going to be my final answer, I'm going to have plus or minus 1/2 x. Now that I've identified my vertices, foci, and asymptotes, I can start to graph. I'm going to start by graphing my vertices. So my vertices are 4, 0, and negative 4, 0. And I want to go ahead and also graph points, my kind of co-vertices, if you were thinking about an ellipse, but it helps me to draw the box that I'm going to need to do for this hyperbola. So I'm going to go ahead and use my b and use that as a point for my y-axis. So I'm going to go up to 2 and down to negative 2. Now I'm going to create a box. The box is going to be to the width. Let's actually use a nice line tool because we want it to be beautiful and straight. I'm also going to use a dashed line to demonstrate that it's not actually part of my graph, it's just helping me to create the graph. So here's I'm going to create a box that is the length and width of my vertices and the co-vertices. And now I want to go ahead and graph those asymptotes. So I'm going to do that in blue. And my asymptotes will go straight through the corners of the box. You could use slope, your knowledge of the slope formula, slope-intercept formula of an equation, and go ahead and graph this on your own, and you'll find that it works the same. But a nice trick is that you can just go right straight through the corners of the box. So if I do that, I start at one corner and go through the other, and I do the opposite. The one thing to remember is that you want to extend it all the way through the graph. So I'm going to go ahead and extend this all the way through so that I can draw my ellipse, or my hyperbola easily. Extend that line all the way through. Okay. So now I've drawn my vertices and my asymptotes. And so now I can go ahead and draw my hyperbola. So because I know it's a horizontal hyperbola, I'm going to go ahead, I'm going to choose another color here. Let's go with purple again because it's my favorite. My hyperbola has a transverse axis that is horizontal. Therefore, my graph is going to be graphed. I'm going to go ahead and approach that. I have to touch my vertices. That's why this one is the vertices, and these we can't really call co-vertices because they're not on the graph itself. So I'm going to go ahead and draw down. My drawing is going to be almost like a parabola that's opening to the left and right. But this is on both sides of the graph. Go down and hit my vertices and go up. And notice how I'm approaching my asymptote but not crossing it. So if you have any questions on graphing hyperbolas, there is a lot of steps to doing it. It's not difficult with practice, but it is just good to get that practice and have all the information that you need there for you. Let's take a look at the next one. It says write an equation of the hyperbola giving its graph. So if we look at this graph, we have our box here. And we can identify what kind of parabola it is. Remember, there was two different kinds. We had one with a horizontal transverse axis or a vertical. Well, this one looks very much like the one we graphed. So we know it's a horizontal transverse axis. So we know it has to be x squared over a squared minus y squared over b squared equals 1. Now that we know that that's the form, we just need to figure out what our a squared and b squared would be. Well, my a squared is that my a is always going to be part of my vertices. So taking a look here, my vertices are plus or minus 4. So if my vertice is plus or minus 4 comma 0, that must mean that my a is 4. And therefore, a squared should be 16. I can figure out what b is by looking at my box. Going up to these points here, I look here, and these points should be 0 comma plus or minus b. Therefore, my b is 3, and my b squared is 9. Once I've identified all of these parts, then I can go ahead and write my equation. X squared over 16 minus y squared over 9 equals 1. Now there's other ways to identify these parts. I could look here and say, okay, I look at these, this is 3/4. That's going to be my b over a, and that way I could identify b and a as well. But there's a couple of different ways to do that by looking at the graph. If you have any questions, please see me or Mr. Daniels, and have a fabulous day.